Hi, I'm Dr. Christopher Sutton. Welcome to my Introduction to GIS video series. In this set of 5 videos, we will discuss map projections in GIS. We will cover what they are, why we use them, how they are created, and how we can modify them. Let's get started. We'll begin with the basic question, what is a map projection? A map projection is the systematic transformation of coordinate positions on a 3D surface to coordinate positions on a 2-dimensional surface. Earth is a 3-dimensional object. As was discussed in an earlier video, it is an oblate spheroid. Maps, on the other hand, are flat 2-dimensional objects, whether they are maps on computer screens or paper maps. The thing to begin with when it comes to map projections is that when we transform locations from the 3-dimensional surface to their respective positions on a 2-dimensional surface, it is impossible to do this without introducing some distortion. So why should we learn about map projections? It is important to understand map projections because they directly affect how spatial data is displayed, analyzed, and interpreted. In GIS, we integrate and analyze spatial information from various sources. Thus, choosing the right projection ensures accuracy and minimizes distortion-related errors. We can categorize map projections in several ways. We can categorize projections by the property that they preserve, whether it's shape, size, distance, or direction. We can categorize map projections based on the surface that we use, whether it's a cylinder, a cone, or a plane. And finally, we can categorize map projections on the approach that we take, whether it's geometric, mathematical, or a compromise of multiple methods. I will have individual videos discussing each of these. Let's look at some examples of why projection choice might matter. In navigation, for example, using an unsuitable projection can result in navigation errors. Such errors can have life and death consequences at sea. In land management, using an unsuitable projection can result in inaccurate area calculations for land parcels. These can have legal and financial implications. And in emergency response, disaster planning requires mapping precision, and rescue operations require coordinate accuracy. Using an unsuitable projection can be detrimental to such operations. Let's wrap up this video by discussing some common misconceptions that we have about map projections. First is the myth that there is one correct or best map projection. In reality, every map projection serves a specific purpose. The best projection depends on the map's scale, location, and application. Another myth is that some projections are more accurate than others. In reality, all projections are accurate for their intended purpose. An example of this is the Mercator projection, which you might be familiar with. If not, I will discuss it in an upcoming video. There is the myth that the Mercator projection is wrong and should never be used. In reality, the Mercator projection is perfectly fine for its original purpose, which is nautical navigation. Finally, we have the myth that all projection distortions are visually obvious. In reality, some distortions are not easily perceived, but can impact analysis and decision-making. Now that you have been introduced to map projections, we will take the next 3 videos to discuss how we classify map projections so we can understand how to better use them in GIS projects.